Okay. Greetings everyone. Today inshallah we will continue on the previous session. In the previous session, this is our second lecture for this fourth week. So inshallah it will be fine. Okay. We will start from the raw operations of elementary matrices and also in the solution of a system of equation. I want to grab your attention about some special cases for a system of equation. A system of linear equations, AX is equal B, it's called the Cramer system. So Cramer, it's related to determinants, but the Cramer name is given also for the systems of equations once you have a unique solution. So once you hear a Cramer system, it's also an abbreviation for a singular solution or just only one solution for a system of equations, okay? Okay, here is telling you that, please observe that any Cramer system, AX equal B, is determined, consistent. Let alpha 1 and alpha n is determined and consistent. It means a unique solution. It means it will have just only one solution. Okay? Let alpha 1 up to alpha n belongs to K. Those are the proposed unknowns or the values of these unknowns. Be a solution of the system. Then A times the unknown column equal to B. If you multiply A minus 1 on both sides, you will end up having all the variables equal A minus 1 times B, and that's the soul of the methods. It's just introducing what we are doing. In a Cramer system, we can compute the solution through the matrix A minus 1. He's stating that if you have just only one solution, if you get the inverse of the coefficient matrix and multiply it by the result, you will have a solution for your system. It's exactly like what we did previously. And don't forget that once we had the inversion or the inverse previously, we already tried methods like this. Any questions? Okay. Example for a system like this. This system is really very simple. If you remark, we have x plus y equal 1, y plus z equal 2, x plus y plus z equal 0. If I want to solve this system, I can solve it either by using Gauss-Jordan method that we already saw in the previous chapter. We can get a minus 1 by two methods. All of you know them. The method of Gauss elimination and also by the cofactor method, the adjoint matrix. شباب انتوا فاهمين انا بقول ايه؟ انا اقدر اجيب الانفرس للماتريكس دي بطريقتين، الكل مجمعهم. All of you understand or remember the two methods getting the inverse, okay? So if I want to solve this system and to be sure that it's a Cramer system, I can simply find the A minus 1 or the inverse of the coefficient matrix. I will start by writing, first of all, be sure that this system is arranged. So it's gonna be the coefficient matrix 1, then I will have 0 and 1, and for the y, I will have 1, y is equal to 1 and 1 also. For the z variables, I will have 0 for the first equation, then I will have positive 1 and 1, and this system is multiplied by the unknown column, which is x, y, and z. Okay. So it's gonna be x equal to 1, 0, and 1. For y, it's gonna be 1, 1, 1, and 1. And for the z, it's gonna be 0, z is equal to 1 and 1, 2. I will have x, y, and z. This is x, y, and z. And the result will be 1, 2, and 0. So that's mainly the system of equations, but in a matrix form. If I want to get the inverse, it's very, very simple. Here we go. That's gonna be 1, 0, 1, 1, 1, 1. 0, 1, and 1. The simplest method that I want you to remember is to write a unit matrix from the same dimension on the sides. That's the equivalence line, as we already know. So I need to get the inverse of this matrix. Ziyad, what's the first step? What should we do in order to get the inverse? What's the first step?
First column 0.
Yes, exactly right. So I will multiply the first row by -1, then I will add it on the third row. Okay, let's do it. So once more, if I want to do this, this is gonna be the new matrix that I will have. I will write the first row as it is, 1, 1, and 0, 1, 0, and 0, multiplying -1 and adding on the second row. So it's gonna be 0, 1, and 1, 0, 1, and 0. -1 plus 1 is equal to 0. -1 plus 1 is gonna equal to 0. -0 plus 1 is gonna be +1. -1 plus 0 is gonna be a -1. -0 times 0, 0. -0 plus 1, so it's gonna be a +1. So I've succeeded in getting the first card already correct. The second step, Farid, what to do? The pivot of the second row is correct, so I need to be sure that +1 is equal to 0. How to do it?
Times
Negative,
-1 plus
and then add it
-4.
on the first row. Yes, exactly right. So simply, the first row will be once more multiplying by -1 and adding on the first row. It's gonna be a 1. -1 plus 1 is gonna be 0. -1 plus 0 is gonna be a -1. Then negative times 0 plus 1 is +1. -1 plus 0, it is -1. 0 plus 0 is gonna be 0. So I've adjusted the first row. So it's 0, 1, 1, 0, 1, and 0. And for the last row, it is 0, 0, 1, -1, 0, and 1. Now for the final step. So like, I need to adjust the last matrix or to get the inverse, and this is the last step. So I'm going to focus with the last row, which is 0, 0, 1, and the remaining numbers are -1, 0, and +1. How to be sure that this value is equal to 0 in the new matrix? How to do it? I will try to use this pivot to force this number to be a 0. So it means I will multiply the last row by the same number but with opposite sign. So I will multiply in -1. Okay, multiply. -1 plus -1 times 0 is 0 plus 0. It's gonna be 0. -1 times 0 plus 1, it's 1. -1 plus 1, so the result will be 0. Negative times -1 is gonna be +1 plus 0, +1. Negative times 0 plus 1, it's gonna be +1. Negative times 1, -1 plus 0, so it's gonna be -1. Okay, once more. I need this element to be 0. But it is already -1. So I will multiply in same number but with opposite sign. So in +1, multiply. Multiplying in +1 and the adding, it's like addition exactly. So 0 plus 1, it's gonna be 1. Then 0 plus 0, it's gonna be 0. 1 plus -1, it's gonna be 0. -1 plus 1, it's gonna be 0 also. Then 0 plus -1, it's gonna be a -1. 1 plus 0, so it's gonna be a +1. As you can see, here we got the reduced echelon form. So what we have now is the inverse. So a minus 1 simply is 0, 1, -1, -1, 1 and 0, 1, -1, and +1. If I want to solve this system of equations, now I can. It's very, very simple. I have the inverse with me. So all I have to do is to consider this system as the truth. It's ax equal to b. So if I multiplied a minus 1 on both sides, it's gonna be a minus 1 times ax equal to a minus 1b. That's x equal to a -1 times b. Also, of course, all of this are really very simple for you, and we already did that previously. So all I have to do to get the solution of this system is to multiply a minus 1 times b, and that's the column of the unknowns value. So I will multiply this matrix by the results, which is 1, 2, and 0, and so I will get the solution of this system of equation, of course, by simply multiplying. Any questions? ها تمام؟ Okay, perfect. ها تمام؟ زياد, okay? طيب تمام. That's the system of equations. First of all, getting the inverse, then multiplying by 1, 2, 3, by 1, 2, and 0, so the result will be negative 2, 3, and the negative 1. The multiplication process, do you know how to multiply them together? How to multiply these two matrices? Yes, I will multiply the row by the column. Okay, step by step, each element will be multiplied and added together. So it's gonna be 0 times 1, it's gonna be 0, negative 1 times 2, so it's gonna come up to negative 2, plus 1 times 0, it's gonna be 0, so the first row is gonna be negative 2. Do it again for the second row, so it's gonna be a 1, plus 2, which is 3, and that's the result. Multiply the third row by the column, negative 1 times 1 is negative 1, that's a 0 and that's a 0, so these are the results as you can see. It's very simple. Okay, perfect. This system is called a Cramer system, Fatin. Why it's called a Cramer system? Simply because this matrix is invertible. So if I said to you, this system is a Cramer, so the matrix, the coefficient matrix is invertible, they are the same. Okay, once more, he's explaining to you what we did exactly, playing with the rows. If you got the unit matrix, you will get your inverse, and that's an explanation of what we did exactly step by step. So there is no more information in this slide. I will start talking about determinants now, which is chapter 3. Chapter 3 is really very important. If you remark, I've sent you the exam of I believe 23, 24, and also of last year for the first midterm. Just to make you, I was asked about it from some of you, but also I want you to imagine how the questions are built up together and how they are connected with chapter 1, chapter 2, and more than that, how it is connected together. We will start with the determinants. We already know about the determinants, how to evaluate a 2 by 2 determinant, how to evaluate a 3 by 3 determinant, either by using Sarah's rule or by the cofactor or Gauss method. I want you to remember this method. I will start by this method, although it is a little bit different than the arrangement that we have on the slides of Lisbon. But since we are still talking about a system of equations, it's very, very nice to see how to deal with a system of equation using Cramer method. Cramer method, especially that we already mentioned the Cramer for the singular solution. That's just a little bit history about Cramer's rule. It's related to Gabriel Cramer, so it was within the beginning of the 17th century, as you can see. It's really very simple method. And it is successful only with invertible matrices. So one advantage of this method, it can easily find a unique solution for a system of equations, but it can't handle inconsistent systems or infinitely many number of solutions. What's meant by a consistent or a consistent indeterminate system. Okay? So let's see how Cramer method is done. It's really very simple. Let's do the 2 by 2, then the 3 by 3. For the 2 by 2 example, you have 3 of an x1 plus x2 equal to 5. Then you have x1 plus 2x2 equal to 4. The solution is really very simple. All I have to do is to evaluate n plus 1 determinants. All of them 2 by 2, since we have just only 2 unknowns. So I will start with the determinant of the coefficient matrix. That's the symbol of a determinant. So like the symbol of a matrix, it's like a square brackets. But for the determinants, it's just only 2 lines. I will start writing the numbers, which are 3, 1, 1, and 2. The first step to be sure that grammar is successful with solving this system of equation is to evaluate this determinant. How we evaluate this determinant? We will multiply the elements of the principal diagonal minus the elements of the secondary diagonal. I believe within the next lecture, I will go step by step by defining why we do this in details. Once we go to the theoretical part of this chapter. So it's gonna be simply 3 times 2 minus 1 times 1. The result will be 6 minus 1, which is 5. So it doesn't equal to 0. The grammar system doesn't solve any system when the coefficient matrix is equal to 0. So for grammar method to work, the coefficient matrix must be non-singular matrix. What we mean once more by non-singular matrix? The matrices where their determinant doesn't equal to 0. So actually now I'm sure that this system will have a unique solution, okay? And the rank is equal to 2. Also, say by the end of chapter 3, you will find the system of equations is linked to the ranks, is linked to the determinants. They are all linked together. So from the first step, we already know that this is invertible matrix, number 1. Number 2, it's a grammar method. Number 3, it's a unique solution. Okay? The classification of this system, it's a consistent determinant system. All of this information we already know now. Then I will have to evaluate delta 1 and delta 2. Delta 1 stands for the determinant that I will form it like this. Miss Fatin, I will replace the first column, okay, which is the column of the first variable, which is x1, by the results, which is 5 and 4. I will put 5 and 4 in here. Then the rest of this determinant will be exactly the same. So it's going to be 1 and 2. So that's the coefficient matrix. That's the determinant relative to x1. Let's say determinant of x1. Okay, and same way like I will get the determinant of x2. How to get the determinant of x2? Exactly like what I did previously. I will first of all write the first column as it is in the coefficient matrix. Then I will replace the second column by the results, which is 5 and 4. Then I will evaluate the values of these determinants once more. So it's going to be 5 times 2 minus 1 times 4. 5 times 2 is 10 minus 4, so the result will be 6. Then I will determine the third determinant, which is 3 times 4 is 12 minus 5 times 1, which is 5. 12 minus 5, it's gonna come up to, I believe, 7. Now I have the results. From the values of these determinant, I have the solution. x1 will equal to delta of x1 divided by delta, and the x2, it's delta of x2 divided by delta. So simply, all I have to do is to divide 6 over 5. Then I will divide 7 over 5, and that's the solution of this system of equations. معايا مستر زياد؟ تمام؟ فريد؟ Okay, so I will start, as you can see, by the system of equations, getting the determinant of the coefficient matrix, replacing each column by the result, as you can see. Then I will divide them on each other, dividing the determinant relative to x1 on delta, then dividing the determinant relative to x2 over delta, and then the results are. This is very, very simple, and it's working beautifully, especially with systems 2 by 2. Just only 3 determinants, as we did. This is number 1, number 2, and number 3. And the values are really very simple. x1 is delta 1 over delta, so it's going to come up to 6 over 7, and x2 is 7 over 5. Simple. If we want to solve this system, which is 3 by 3, okay? If I want to solve this system, which is 3 by 3, it's going to be similar to this one, but before I erase this problem. Remark that to solve the system 2 by 2, we had to evaluate how many determinants? 3. To solve a system of 3 equations and 3 unknowns, I will have to evaluate how many determinants?
4.
4 of them. And it's very, very simple. I will start, I can do it as fast as possible. So I can start with writing the determinant of the coefficient matrix, which is gonna be 10, as you can see. Oh, careful. As you can see here, this is 10 x1, but this is x2. I want you to take a good care of this well-arranged equations, because usually in exams, and once you are writing very quickly, you may run or write these numbers not in a correct way. So the correct way is going to be 10, then I will have -3, then I will have 5, then for the values of x2 it's going to be a negative of a 7, then I will have +2, then I will have -1. So you will have to be sure that your equations are correctly and well arranged together. The first value for x3 is equal to 0. The other two values are 6 and 5. That's for the coefficient matrix. So once more, it's 10, -3 and 5, -7, +2 and the -1. Then you will have 0, 6 and 5. I want to evaluate the value. How to do it? I believe the simplest is to use Sarah's rule. Am I right? So how to use Sarah's rule?
دكتور
تفضل.
واحنا كتبنا الماتريكس دي بطريقه مختلفه صح؟
لا. ايه الاختلاف؟
بتبقى 10 2 5 7 3 negative 1
10 to 5. But variables are x1. The value of or the coefficients. Yes.
sorry.
Okay. The coefficients. This is what I'm talking about. The coefficients here. It's 10 for x1. This is x1, which is -3. Then this is x1 is 5. This is what I'm talking about. You have to be sure that they are well arranged. Okay. And it is the same from the beginning. Okay. Okay. Tell me how to evaluate using Saras once more. Anyone to remember? Multiplying 10 times 2 times 5. 10 times 2 times 5. Then I will take the elements of the base of the upper triangle and multiply it in the head of the lower triangle. So I will multiply -7 times 6, then times 5. -7, then times 6, then times 5. Plus, I will multiply the elements beneath the principal diagonal, which are -3 times -1, -3 times -1, then multiply them by the upper head, which is 0. So it's not going to be evaluated. Okay, I will do it once more, but with the secondary diagonal. Minus, and I will go for the secondary diagonal. Once more, that's the secondary diagonal. Here we go. That's the secondary diagonal. So it's going to be 0 times 2 times 5. Then minus 6 times -1 times 10. 6 times -1 times 10. Then minus -7 times -3 times 5. -7 times -3 times 5. And then I will have the value of this determinant. So that's the first step. I can go now, of course, if this value is equal to 0, we can't use Cramer method. It will be used only when the coefficient determinant is not equal to 0. Now I can get x1. It will be this determinant, which is once more 10, -3 and 5, -7, 2 and the -1, 0, 6 and the 5, and the determinant on the denominator will be exactly the same, -7, 2 and the -1, 0, 6 and the 5, and just only with minor change, I will change the first column, which is the coefficients of x1, by the result. The results are 7, 4, and 6. So I will insert here 7, 4, and 6. That's the first value. If I want to get the second value, I will write them all. If I want to get x2, x2 is gonna also be really very simple. x2 is gonna equal to same denominator. The denominator will be the same, which is 10, negative 3, and 5, negative 7, 2, and the negative 1, 0, 6, and the 5. But for the determinant on the denominator, it's gonna be 10, negative 3, and the 5, 0, 6, and the 5. And I will change the second column by the result column, which is 7, and that's 7, and that's 4, okay, and 6. And for the last variable, which is x3, it's gonna be similar to all of this. It's gonna be a 10, negative 3, and 5, then negative 7, 2, and negative 1, 0, 6, and 5, and the determinant on the denominator will be exactly the same, but with 7, that's a 7, 4, and 6. The other two columns will remain exactly the same, negative 7, 2, and the negative 1. This is 2, negative 3, and the 5, and start evaluating each of these determinants. So, if you remark, the determinant, the value of the coefficient matrix is negative 155, which doesn't equal to 0. So now I can divide on each one of them. This is minus 155 divided by minus 155. Same way like divided by minus 155. Then I will evaluate each and every determinant of these three determinants. You will have your results very fast. Okay? What's the problem with grammar, Mrs. Becky? It has to be invertible, yes. And if the system is 4 by 4, can you imagine the effort that we have? A 4 by 4 system, it means you will have to evaluate 5 4 by 4 determinants. Each one of them, you will not gonna be able to evaluate it unless you expand it to 4 3 by 3. So just trying to solve a system of equation 4 by 4, you will end up having enormous number of 3 by 3 determinants. If I went to 5 6 by 6 or something like this, this is mainly the main obstacle using Cramer's method in solving systems of equations. Also, it's really very simple, as you can see. The determinants is really very simple to evaluate and so on, but it's handleable till you have two equations and two unknowns go 3 by 3, and that's it. Okay? Any questions? Okay, very good. I want to go through some problems on determinants with you. Those are some problems from the exercise book. They are really very simple. He is asking you about the minors or some of the elements, as we will see next lecture. It's very, very simple. So he wants you to compute the determinant of the following matrices. So the determinant of this matrix, how it's gonna be? It's gonna be 1 times 2 minus 1. The determinant of this matrix is gonna be positive 1 minus 4, which is negative 3, as you can see. This one too, the determinant will be 1 times negative 1, which is negative 1, minus I squared. I squared is negative 1. Am I right? So it's gonna be, I think, positive 2. For going through this matrix, he's giving you a matrix. Let A be this matrix, belongs to M3 by 3. With A doesn't equal, compute the determinant of A using Sarah's rule. Of course, you know how to evaluate Sarah's rule. I will multiply the elements of the principal diagonal. Then multiplying A times A times A to the power of negative 1. then multiplying a minus 1 times a minus 1 times a square, then minus, I will do them on the secondary diagonal. So I will multiply the elements of the secondary diagonal, then minus the elements of the lower base of the lower triangle in the upper head, and vice versa. Okay, so it's really very simple. For this guy, he is asking you to find the algebraic complements. It's called the algebraic complements. We will take it next time. It's the it's the cofactors of each of the elements that I will get. If you remember how to get the inverse, Farid, in the previous sessions, I believe before 2 sessions or something like this, using the cofactor method, if you remember. All I have to do is to go for the cofactor method, or the cofactor for the element 1, 1. We call it an algebraic complement, the algebraic complement of the element A11. How to evaluate it? So like, I will go to 1, 1. What's the element 1, 1 in this matrix? It is positive 1. I will eliminate the row and the column. I will eliminate the row and the column. So the remaining determinant will be, just doing this, the remaining determinant will be, this is A, the algebraic complement, relative to A11. It's gonna be the determinant 2, 4, 1, and 2. And both the sign relative to this algebraic complement. Mr. Ziyad, sign بكام؟ sign positive. طب انت عرفت منين انها positive? Because it's a negative 1 to the power of 1 plus 1. I will add these two numbers together. So getting the determinant, okay, relative to this position, and using the sign rule. The sign rule is very, very simple. Do you remember this? ندى؟ معايا في ده؟ اوكي سهل صح؟ ها؟ تمام؟ فاتن اوكي؟ طيب I need the algebraic complement of element A32. Any ideas? It's gonna be, huh? Am I right? Then 3 by 2, which means third row, second column. Ziyad, ماليني numbers.
1
أيوة. صح؟ ما هو 3 by 2 مش كده برضو؟ third row ده third row صح؟ second column اللي هو ده يبقى 1 negative 1 3 and 4 ماشي الحال؟ طبعا I can evaluate it really very simple. This is gonna be 2 times 2, it's gonna be 4 minus 4, so the algebraic complement is equal to 0. This one is gonna be 4, then don't forget minus negative 3, so it's gonna be a 7 times the negative, so it's gonna be a negative 7, and so on. Those are some of the problems that you will find in the exercise. I want you to solve more. Of course, I want you to remember how we get the inverse for a determinant. For a determinant A, how to get its inverse using the determinants. Anyone remember the empirical rule? Fatin? Can you get the inverse using the empirical rule?
Yes.
انا بس استخدم الامبيريكال رول بسرعه. هنا تقدري تعمليه على طول، سهل قوي. ها؟ مظبوط صح؟ ال A minus 1 يساوي 1 over 5 times 1 minus 3 over 2. Yes, you are right. 5 minus 1. 5 times 1 minus 3 times 2. That's the first step. The second step, I will replace the position of these two elements, the principal diagonal, and then changing the sign of the sides. Are you with me, Sulay? Okay, once more. How to get the inverse? It's very, very simple. I will multiply the elements of the principal diagonal minus the elements of the secondary diagonal, which means you are evaluating the determinant. You will divide on it. Then I will replace the elements on the principal diagonal, Ms. Fatin, so it's going to be 1 and 3, and get those numbers but with opposite sign. Then I will finish it. So it's going to equal to, I believe, negative 1 multiplied by all of this. So it's going to come up to negative 1, 2, 3 and -5. That's the inverse of a 2 by 2, of course, matrix. This is the empirical rule. That's the exact method evaluating the determinant, and we already have it previously. Those are the algebraic complements relative to each element after making a transpose for the evaluation. فريدو معايا؟ صح؟ اهو A11, A12, A21, A22. الستيب اللي بعديه, of course, I will divide on the value of the cofactor, and that's the inverse of this matrix. If I have 3 by 3 nada, the process will be exactly the same. I will have to evaluate the algebraic complements, then I will make a transpose for them. I will get the adjoint matrix, those are the algebraic complements, all of them. Then I will divide on the determinant, that's gonna be the inverse of this matrix. Okay. I believe we already did that previously. صح؟ في مشاكل؟ حلو، جميل.
ها لا في حاجة خلصت مكتوب ثانك
Okay.
اها
I will stop today at this slide.
هتخدعنا
Oh, okay, but before you go,
لو ما وافقتش مش هيقلها يوم الخميس
before you go, I want you to be familiar with this. مستر زياد.
ايه ده احنا ما خلصناش؟
مستر زياد بحبك.
حبيبي
Okay, Mr. Ziyad, for all of you. This is exam 23, and it was exactly like the exam of the previous year and for us, till the time being. The exam is really very nice, okay, well put together, as I told you, but it needs a very good study in order to be able to get your marks in it. He will start with this impressive statement. Any question with a treble sign, you may have to mark one or several options. This is what I told you previously. Okay, or even none of the options. Of course,